Hello students, welcome back. Let us resume our discussion in section 2. Previously we completed 2.3 and then 2.4. Now let's go to 2.5. This time we are looking at two graphs in a single viewing window, but it doesn't matter as a matter of fact. Even if you have two separate windows, red graph on the left and blue graph on the right, or vice versa, it wouldn't have mattered. Okay, let's answer the questions here. And part A concerns only red graph. Find the average rate of change in the interval 1 to 6. So f of 6 minus f of 1 divided by 6 minus 1. So if you can find f of 1 and then f of 6, then you're through, because you can plug in f of 1 right here, f of 6 right there, and then 6 minus 1 is 5. So you can do this kind of computation easily. So what is f of 1? Let's see. We have to start from axis 1 and move vertically until you hit the point on the graph. Right here, look at my mouse. Right here, look at my mouse, and then it hit this lattice point. What's the y-coordinate value? It's 4. Do you see that? How about 6? 1, 2, 3, 4, 5, 6. And you have to move vertically until you hit the point on the graph. And we are looking at f of 6, so red graph only. Right here, what's the y-coordinate value? 3. Alright, so plug in 3 and then plug in 4 approximately, in appropriate places, excuse me, and do your computation. You're going to get negative 1/5. So average rate of change, yeah, that appears a lot, but as a matter of fact, any kind of expression would have been okay. Just like 2.3, this was not really special quantity, average rate of change or anything, but if you have f of 2, f of 6, and f of 4, then you can answer the question. Likewise here, if you find f of 1 and f of 6, you can answer the question. Next, find the net change. What is net change? This quantity is called a net change. Just the difference, g of 8 minus g of 4. Okay, alright. Let's find out g of 8 and g of 4 respectively, and then answer the net change question. G of 8, where is it? 1, 2, 3, 4, 5, 6, 7, 8 here. And then what's the y-coordinate of blue graph? See this point? What's the y-coordinate? 2, 3, 4, 5. Did I do this right? How about g of 4? 1, 2, 3, 4. Alright. And vertically, okay, that y-coordinate is 2. So the net change, g of 8 minus g of 4 will be 5 minus 2, that's going to be 3. Oops. Okay, alright, wrong key, sorry about that. So these kind of problems, I wanted to expose you to some terms. Average rate of change, what is it? Net change, what is it? But in the end, reading graphs. Given x coordinate, you can find out the function value by starting and then moving vertically and then hit a point on the graph and move horizontally to find out the y-coordinate value. Next, let's consider p of x, which is product f of x times g of x, and q of x, which is quotient f of x over g of x. Let's find p of 2 minus q of 2. So P of 2 minus Q of 2. What is it? What is P of 2? F of 2 times G of 2. P is defined as a product, remember? And then Q of 2, F of 2 in this case, over G of 2. That's the quantity you have to find out. Make sense? But remember, F of 2 is coming from the graph of F, which is red, and G of 2 must come from the graph of G, which is blue here. And here, F of 2 is red, G of 2 is blue. Excuse me, I hit the wrong key. Okay. Okay, one at a time. What is F of 2? X is 2 and move vertically until you hit a point on the red graph. What is that y-coordinate value? Did you get 6? No, it is 5. 2, 3, 4, 5. Yeah, 5. So 5 times G of 2 minus 5 over G of 2. So F of 2 is 5. A little bit bigger font will be helpful. G of 2 we have yet to find out. How's that? Okay, alright, if you find G of 2, then you're through G of 2. Let's see, X is 2 and move up to graph of G, blue, and that is 3. Did I get it right? 3? So 5 times 3 minus 5/3. 15 minus 5/3 and 40 over 3. Yeah, you can punch in the calculator and do the computation, no problem there. Did I do this right? Yeah, I must have. Yeah, 40 divided by 3. So it is all about reading graphs, but we have 2 graphs, so we have to read 2 different graphs in appropriate place, and color coding does help. Sometimes I'm going to give you 2 graphs separately, graph of F on the left and graph of G on the right. Sometimes both of them at the same time, and it's unlikely that I'm going to give you 3 graphs in the same viewing window. It's too hard to find out. But I've seen problems like that. 3 graphs in the same viewing window, 3 different colors. Oh, I've seen worse. All black, 3 graphs. I'll try not to do those. If I give you 3 graphs, then it's likely that I'll give you 3 separate graphs so that it's easier to read. Next, find all values such that f of x is equal to 4. Yeah, this is inverse problem from y-coordinate, horizontal, and then find x-coordinate and move down. But you have to do that for the red graph. Okay, alright. How do you do that? 1, 2, 3, 2, 3, 4 is right here. And then if you do this horizontal line, we have this crossing point right here and that crossing point right there, and then we have x equals to 1 and then x equals to 3. It's really hard to see, so let's get out of this and then I'll just show you the answer key. Okay, alright, in this answer key I disregarded blue graph because I'm looking only the red graph, and y is 4, hit these 2 and then read the x coordinates. Drop down, we get the x coordinates. Okay, finally Find all x values such that g of x is greater than or equal to 3. G of x is greater than or equal to 3. Y-coordinate is greater than or equal to 3. 1, 2, 3 is here, so we are looking at this horizontal line. So 1, 2, 3, this horizontal line. Am I right? 1, 2, 3, yeah, here. And that's y equal to 3. If you want y is greater than or equal to 3, you have to consider above that only. In other words, we have to focus upon this portion of the graph and then this portion of the graph only, and disregard the rest. We are talking about g here, so certainly not f, and those down here, they're out of consideration because g of x is greater than or equal to 3. So this portion here will give me an x interval, -2 to +2, -1 to +2, I guess, and then from here to there, 2, 3, 4, 5, 6, 7, 8 to 9. Is it 7 to 8? Do appropriate counting. Let's see, what do I have here? Oh, here I assume that this graph just moves off forever. Yeah, okay, that's usual convention. If this had been ending, it would have ended with a solid dot here. Solid dot here, or maybe empty dot. Either way, big dot would have been there, but no, it's just extending toward the edge. So assume that it goes on forever. So -infinity to +2, and then 7 to +infinity. So we have union of two intervals here because we are looking at two curve pieces. And then as for the infinity part, if you miss that, nobody will take off any point. Oh, excuse me. Computer may take off some points because it's based upon cheap AI, but in general, if this had been human grader, then that kind of little thing really do not cause too much trouble. It is a matter of getting this y equals to 3 or above, and then getting appropriate portion of the graph. Okay, all right. So much for two graph problems. And then we have a little bit more problems here. I will consider those later. This problem here I de-emphasize in gray because we may not have enough time. I don't know what I'll do. I'll record those, and shall I make those as the regular component, or shall I make those as optional video? I'll think about those. I still have plenty of time until week 5 hits. Okay, so much for two graph problems.